Welcome to everybody. Hope you had a wonderful long weekend. I know a lot of you were in my PAA 9, I think most of you. So I just saw you, and we're moving on in math. So what I had asked last week is because I did a little bit more on the house cleaning end of things and a little less as in zero instruction. I asked you to look through the video and textbook questions from 2.1 on your own. So hopefully you had a chance to do that. I did not have, I think I had one question on the weekend that I answered, but I didn't see anything else. So hopefully that was all making sense. Your math class is a full year class, so it's actually a 200-hour class, which is why you are only expected to spend an hour per day on it, whereas your quarter classes, you need to spend 2 hours per day on it. And to be honest, if you're the type of person who can do the textbook questions and in 10 minutes and then do the assignment in another 10 or 15 minutes and do everything correctly, well, that's great. It just takes you less time than it does other people. Do what you need to do in order to meet your educational goals. And for some of you, that goal in this class might be getting a mark of 100%. For some of you, it might be just getting above 50 or getting above 60, to each their own. So make sure you set a goal for yourself and do the best you can to reach that goal. And don't hesitate to reach out to me if you're struggling with a question. When I taught math last year for the online grade 9s, very, very typically students would send me an email saying, I'm fine up until question 11A in the textbook practice questions. And that's the best way for me to give you some targeted, direct, and timely feedback. Because if you have demonstrated to me that you can do some of the work in the correctly for the textbook questions, clearly you've gone through the tutorial videos, clearly you've paid attention during the live sessions, and you've made a good attempt, and you've told me exactly where you're getting stuck. And I've done this class enough times that usually I can look at a question and know more or less where you're being, where the confusing information is. And then I'll either send back some notes or a little picture of me doing a similar question, or even a video of me doing a similar question. And 99 times out of 100, that helps the student get past that particular bump and keep moving forward. So it's very important that if you struggle with a concept or a question, and if you keep trying it and you just keep getting the wrong answer, because don't forget, you have access to all the answers for the textbook questions. Insanity is roughly defined as doing things the same way and expecting a different result, repeatedly the same way and expecting a different result. So if you try the question and you get a different answer, and you look at what you've done and you think you've done it correctly, you try again, you get the wrong answer again. There's no sense in continuing to throw that exact same approach at it. Either try a different approach, or probably more likely just send me a quick email saying, I keep getting the wrong answer on question 11B, and I will say, oh, you're probably missing this. Or even better, you could send me a picture of what you've done on the question and how you're getting the wrong answer, and I can look at that and say, oh, you forgot to carry the 1 or whatever it is. And usually those problems can be solved pretty quickly. So that being said, are there any questions from the materials on 2.1? If there's some due dates up there that are completely whack, it is because it's probably from the last time I taught this class and they weren't changed at the beginning of the quarter 1. So I will go up and I will change all of those due dates to make them make sense. Otherwise, you're going to need a DeLorean and a flux capacitor in order to go back in time and hit your due dates. So thank you for that notice there, Dave. I didn't even think about that. I will change those to something that makes more sense. In the meantime, and in between time, as Ed Whalen would say, if I go to sorry, I just want to get to the right page here. Come on. There we go. Okay, so I just wanted to point to class website. I'll go into student view, so it looks the way that yours looks. Okay, so don't forget, I'm going to try and make a habit of posting what we're doing each week and what's due in the announcements. So it'll be there, but it's also in the pacing calendar. And I put up new ones. I put up a new pacing calendar for chapters 2 and 4. Remember, you already did 1 and 3, right? So this is going to take us till the end of December. So we are right here, right? 15. You'll notice this matches up with that little sliver I showed you on the other page. So today I'm going to do a little bit of a live session on this using the workbook. Then tomorrow you should use that hour as a work period. Then we got 2.3 live session on Wednesday, and you should use the rest of the time and the next day to work on 2.3. Hand in is due this day for 2.1, 2.2. Hand in for 2.3 is due on Friday. So if it says hand in on Thursday, that doesn't mean you should be working on it on Thursday. You should be handing it in on Thursday. Your work period for 2.1 and 2.2 is going to be on Tuesday. And then if you need a little extra time, you do a Wednesday. You should be using this Thursday for 2.3. That's why I've got things written out this way. If you stick to the pacing calendar, you shouldn't have any trouble keeping up with the class, even moving ahead a little bit. If you find that you're doing well and you want to move ahead a little bit, that's fine. That doesn't bother me. Just make sure that you understand things clearly. You're able to explain it. You're able to apply what it is that you're learning. And also that, just make sure you're getting good marks. I don't want anybody jumping ahead if they're not, getting 95s to 100 on everything. Okay, there's no sense in it. That being said, this is a course that you can complete somewhat independently, because all of my tutorial videos are up there. You have access to the textbook, and you have access to all of the quizzes, etc. So you can work away. Say you've got a particularly difficult, whatever, English 9 class or something, and you need a little bit more time for that in a week. Well, you could hammer out a week's worth of work in math ahead of time, and then just have extra time to dedicate to that other class. Make sure you're hitting the live sessions though, because they are required for grade 9s. I know not all of you agree with that principle, but it is what it is, and it was set by our school board, and we're all abiding by that, which means I have to take attendance in these live sessions, and if you're not attending, I need to make phone calls and let my vice principal know and whatnot. So hopefully you do get something from the live session, because I will be going through the concepts and in a quicker manner than my videos do them. But remember, attendance is required. That doesn't mean you can't move ahead, but just make sure that you're showing up for the live sessions. I think at the beginning of each live session, I'll just set aside 5 minutes where I can either go through questions that people have asked in email, if I think it's something that everybody would benefit from knowing, or if somebody brings a question to the beginning of the live sessions that we have on Monday or Wednesday, I can start by doing one, sort of live, if I think it's something that everybody would benefit from. If not, I might say I'll do this one with you after the live session. But we'll make it work. However it happens, we'll make it work. I'm looking at my calendar here, and I say it says Exponent and Exponent laws. Clearly that is supposed to be Exponent. I will fix that spelling error post haste. Spelling is normally a strength for me. Okay, so there's November. We've got practice exam that I will go through, and I have a video for, and then the real exam. There's your multiple choice section, there's your written portion, and then we just, we move on. I don't know why that says surface area of right rectangular prisms. It shouldn't. I will fix that as well. You've already done that. I just forgot to put Friday up for some reason. Okay, some other housekeeping stuff. I will flick back to today's notes. Okay, so I didn't see any text questions, so that's fine. Okay, we got took care of that one. Quiz 2.1 to 2.2. Okay, I call them quizzes. When I made the course, I called them quizzes. Ms. Vetter preferred hand-ins. It means the same thing. So if you see quiz 2.1 to 2.2, it's exactly the same as what Ms. Vetter called hand-in. So it doesn't matter. Just in case you're wondering why it says quiz now, I just don't want to go back and change them all. So they're going to be quizzes, but it's really the same thing as hand-ins. As Ms. Vetter, I believe, used to do, I will do the same thing. You get 2 attempts for the quiz. You hand it in. Obviously, it would be best if it was done correctly the first time. But all I'm going to do is I'm either going to mark correct or incorrect and give you a mark. And what that does is it gives you an opportunity to go back and try again. So if you would like to, you can take a second crack at that and fix the questions that you got incorrect and hand them in. You don't have to redo the entire quiz. You could just write out the questions that you got incorrect and your revised solution, and then I'll know if I need to add to your mark or not. And then if you still have it wrong after the second attempt, I'll try to give you a bit more detailed feedback to help you, because the quizzes, they're worth marks, but they're not worth as many marks as the unit exam. The unit exam is the real game day. Okay, so you need to use the quizzes and the textbook practice questions to prepare. So the unit exams, same as last time you wrote one. There's two parts. There's a multiple choice part that's all online. So, you know, when you think you're ready, you can just go in and take that part. I'll open it up on that day. And then there's a longer answer. For the longer answer, I think I mentioned this last live session, and I'm very strict on this, okay? It must be on paper. And you can print off the test and write it in with pencil or whatever, or you can just write out the questions in pencil and then do the answers if you don't have a printer or don't want to print it out. Either is fine, but it has to be on paper. You have to take pictures and you have to combine them into one file. So these are for all the longer answer questions. Has to be on paper. Take pictures just with whatever, a tablet, a smartphone, a digital camera. It doesn't matter to me. And then here's the important part: combine them into one file. It is possible for you to hand in as many pictures as you want. And you know what, frankly, that's not the end of the world if you do that. But it's just as easy for you to create this is a Word doc. Okay. You have access to Microsoft Word and Google Docs. Everybody's got an account. And then there's also, you can save any of these as PDFs. Or if you take pictures on your phone, there's apps that will convert and help you build PDFs. I think I recommended one in the class somewhere. So you should know how to do this already. If you don't, I'm going to take you through it once, and I'll do it with Google Docs. The remainder of this lesson. Sorry. I've got a private question. I'll respond to that in a second here. I'll show you really quickly what I mean by this part here is submitting it as one file. So let's just say that you've taken your pictures and you've got them on your phone and you've transferred them to your computer, or you can do this on your phone too. It doesn't matter, because you can get Google Docs on your phone just as easily as you can on your computer. So let's just say I go to, make sure I'm on the right page here. Come on. Whatever. 3 windows. There we go. Okay, so you're in. Oops. Okay, so do one of two things here. I'll show you both of them because I do think it's important. Okay, the first thing you could do is you could go to office365.com and log in, because you all have access to it. You just go to sign into your account. And then yours might look a little different than mine, but basically you log in with it automatically logged me in, but you log in with your, sign up for a second. So sign in, and then it goes to this page. I don't know why I went to Google it. Sign in. Same thing for Microsoft 365 and all that stuff. It's the same. When you get to the sign-in portal, sorry, it automatically logged me in again. When you get to the sign-in portal, it's just your student number. It's the same way you log into everything else, right? Student number at spsd.sk.ca, and then your regular password. But inside there, you've got access to everything, right? You got access to Word. So you can just open up Word, new blank document. You can, and this is online. If you have it on your computer, that's fine too. So here we go. I'm just type whatever you want, but really what you need to do is, if you're going to use Microsoft Word, just go to Insert, picture from this device. And then it's going to say, okay, what do you want to install? And then you can just grab whatever pictures you want to, whatever you want to grab, right? So I'll put that one in there. Great. So this would be, you doing, this is page number 1 that you wrote on paper, or you printed off the quiz and you wrote your answers in and you did all your work, and there's page number 1. Okay, great. Hit enter a couple times, go to the next page. Okay, insert again. Go insert the next picture from whatever device you're on. Okay, now it's going to be this one. Obviously, your pages are going to, your pictures are going to be of your actual work, not Mega Man, but get the idea? And then at the end, you can either save it as a Word file and download it, or you can save it as a PDF. So if you go to save as, you can see how you say download as PDF, download a copy, download as ODT. If you download it as a PDF, then all you got to do is hand it in to me, right? So download as PDF. Okay, it converted it, then it downloaded it, and it's down here, and I can open it up, and hey, look, there you go. There's all my work. So it's super easy to do that in Word. Google Docs is not much different. You just go to your Google Drive. You guys have been using this. You folks have been using this in elementary. You've been using it probably most of your elementary career. You just go to new. Sorry, that's up here in the menu. New Docs. Start a blank doc. Exact same process. Insert. Whatever. This is quiz 2.1 and 2.2. Go to, thanks. Just go to insert, image. Oops, insert image. Upload from computer, right? Or from your camera or wherever you've got it. Insert, open, blah, blah, blah. Make it a page. And then when you're done, exact same thing, right? You can download as a Word document. You can download as a PDF. PDF's easier for me. So if you can download them as PDFs, that's great. Download as plain text. But you're either going to download it as a Microsoft Word doc, or you're going to download it as a PDF. So I'll just download it as a PDF. And in 1 second, it pops up. There you go. Quiz 2.1, 2.2. I open it up. All your answers are in there. Okay, so really the only thing you have to do is take a picture of it on your phone or your digital camera and put those images on your computer. And then you can use Google Docs or Microsoft Office right on the website in order to do this. It's probably quicker if you've got Microsoft Office or Microsoft Word on your computer, or if you've got an app right on your phone to convert to PDF. Combine into PDF, Android. I recommended one of these, and I use one of these. I just can't remember which one it was. Yeah, it's PDF Merge. That's the one I think I recommended. So this is only if you've well, let me go to Google Play on this one. But this is only if you've got an Android phone. But there's free apps that allow you to take like 5 pictures or more on your phone and then combine them into one PDF. So instead of having to, drag your pictures one at a time into a document, if you get one of these apps, and there's apps on for Apple too, or for iPhones and whatnot too. I know this one because I've used it in Android. So you can do your work with pencil. And then take pictures, say it's 5-page exam. You take 5 pictures, 1 for each page, make sure it's nice and close and nice and clear and fill up the screen. And then it's really easy because you can just open that app and then say which 5 pictures you want to be included in the file, and it'll make a 5-page PDF. And then all you got to do is hand it in. So it's super easy. And if I don't have that listed on the website for this class, I will make sure I do. Let me double check first. I'm pretty sure I put it in there. I usually put it in. Okay, so this stuff is Ms. Vetter's. She's taken out some of my stuff, which is fine. She was teaching it, but I may have to put some stuff back in. So if I refer to something that you can't find, let me know, please. Okay, change all that too. I put it in learning modules. Yoink. All right, instead of me bombing around the website trying to find it, I will just put it up again. Put it at the top of this one. Okay, so I'll find a couple apps for Android and a couple apps for iPhone and put them up there so that if you just want to use your phone for taking pictures and submitting assignments or making the PDF, that's probably the easiest way to do it. At least that's what students have told me in the past. I'll make sure you have that information. Just give me about a half hour after the lesson and I'll make sure that's taken care of. Okay, so that takes care of that. And hopefully everybody by this point knows how to hand in stuff. So if you don't, let me know. I will help you with that, but that should be it. All right, I'm gonna get rid of this, and we will go back to. Okay, you already did 2.1, so I can skip through that. This is gonna be pretty quick. I apologize for this Smart Notebook watermark there. That never did that to me up until literally today, so I need to figure out what's going on there. Okay, so powers of 10 and the zero exponent. Most people, when they practice these, generally take to it very quickly, so I'm not particularly worried about any of you on this. The general rule is you count the zeros, right? So let's just say I have a number, and oops, pen's not working. Come on, pen. Oh, did I freeze? Oh, good grief. Well, that's awesome. I was able to draw a second ago. There we go. All right, I'm back. So let's just say I have the number. Oh, come on. Come on here. Battery. There we go. All right, so let's just say I have any number that starts with a 1 and has a certain number of zeros after it. You can change this into a power of 10 very easily by just counting the zeros. So you always put a 10 because it's powers of 10, not powers of 1. So you put a 10 and then count the zeros, right? So there's 1, 2, 3, 4 zeros. So 10,000 is 10 to the power of 4. It's that simple, right? So it doesn't matter how many zeros you have. I don't even know what number this is. I'm just going to write that many zeros. Okay, I could separate them out into threes. That might give you an idea. Right? What is that? That would be, okay, so that's a million. That's a billion right there. Whatever. It doesn't. I don't need to know. Okay, I can write that as a power of 10 just by counting the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 to the power of 9. 10 to the power of 9 is indeed 1 billion. Okay, so as long as it's written in this form, in standard form with a 1 and a bunch of zeros, you could just write the 10 right away, count the zeros, and then you're never going to get that wrong. So I'm not too worried about any of you with that one. The problem with this unit, that's not a problem, it's just the one area that students tend to get a bit more confused about is zero exponents, and then when you apply negative signs and brackets to powers. That's when students tend to have a bit more difficulty with this particular unit. So if I roll down this chart here and I look at, everybody's pretty comfortable right up to about here, okay, where it's been that whole, right, just count how many zeros. So it's 10, okay, and there's 1 0, so that's 10 to the power of 1 just equals 10, right? You know, 10 to the power of 2, well, that's, you just write a 1 and 2 zeros. So you can go either way, right? You can either go from the 100 to writing it as 10 squared, or you can go from 10 squared to writing it as 100. If you're going from a power, okay, let's say it's 10 to the power of 4. If you're going from a power and you want to write it in standard form, you just write a 1. Don't write a 10, write a 1, and then write the 4 zeros. Okay, that's 3 zeros, sorry, 4 zeros. So you do have to remember that. If you're going this way, just write the 1, not a 10. If you're going the other way, okay, if you're going from 10,000 and you want to get it in the power of 10, well, obviously you have to write the 10 first, and then 1, 2, 3, 4. Okay. So as long as you can remember that, you're in good shape. That's typically not what causes issues. What causes some issues in this, whoops, eraser, crap. There it is. That's not an eraser, that's an eraser. Okay, so what causes some difficulty, usually not much, is the zero property. And all you have to remember is that anything to the power of 0 is 1. Anything to power of 0 is 1. Doesn't matter what it is. It could be 2 to the power of 0. It could be 4 to the power of 0. It could be 99 to the power of 0. All of those still equal 1. And why is that the case? Well, I think this is probably the best way I've had it explained to me when I was a student, so I'll try the same thing. Most people at this stage of their math career recognize that when you have a division statement, remember this can be written like this as well, but you're moving on in math, you're probably going to see it in fractional format more often than you're going to see it in this format. Most people are at the point where they know if they divide one number by itself, they get 1. So it doesn't matter. 5 over 5 is really 5 divided by 5 is 1. And then if you write it this way, it's fine. It's 5 divided by 5 equals 1. Some people even write it like this. 5 divided by 5 equals 1. It doesn't matter what that number is. It could be. I just found a better way to erase. No, I didn't. Never mind. Ignore that. Ignore that failure. Okay, so most people are pretty good at this, and it doesn't matter what the number is. It could be 104. If you divide it by 104, it's still 1. So anything divided by itself is 1. So here's a rule, an exponent rule, or law, I guess it is. And that is when you are dividing powers with the same base. So let's say the base is 2 and the power is 3, or the exponent is 3. The whole power is 2 to the power of 3. When you're dividing powers with the same base, so they both have a 2, what you are actually doing with the law is you just write the base, okay, and then you do this one subtract that one. So it's the one on top, the one in the numerator, subtract the exponent in the denominator. So that gives us, we don't change the 2, and then 3 minus 2 is 1, okay, which gives us 2. So if we were to do this math a different way without using the power law, we would say 2 to the power of 3 is 8, and then 2 to the power of 2 is 4, and then 8 divided by 4 is 2. We get the same number, right? Because that was easy math, and doing, you know, smaller powers is pretty easy. But once we start getting bigger powers, like let's say 5 to the power of 17 divided by 5 to the power of 12, I don't want you to put 5 to the power of 17 in your calculator because you're going to start breaking stuff. So that's why the laws of exponents exist, to make our life easier. Okay. Now, a very, very pertinent question was just asked, and that is, what happens if the one on the bottom is smaller? And that's a great question because we need to know that. So let's just go back to our same question, and let's say that you had 2 to the power of 2, and over this time, we've got 2 to the power of 3 on the bottom. Okay. So the way I showed you only works when this number in the numerator, the exponent in the numerator, is bigger than the exponent in the denominator. Keep in mind, this only works when the base is the same, right? I've got 2 as my base. It doesn't work if you can't use this law if you've got something like this. You can't just go, well, that's 2 times 6 to the power of 4 minus 8. That's not how math works. They have to have the same base. Okay, so always check that first, right? So the base is the same. It's 2. The exponents are different, but this time we've got a bigger exponent in the denominator, right? So the process this time is a little different. You just put 1 on top, okay? And then you put what's left over. So you would do 2 to the power of 3 minus 2 on this one. So it's really 1 over 2. Okay. I should do that more completely. So you put a 1 on top, then you put 2, and then 3 minus 2. So it's this one minus whatever's on top. This is only if the bottom power okay, or the exponent in the bottom power is bigger. So then you'd be left with 1 over 2 to the power of 3 minus 2 is 1, which we know is just 1 over 2, which is a half, right? If we take this and do it sort of the long way, well, 2 to the power of 2 is 4, right? And then 2 to the power of 3, that's 2 times 2 times 2 is 8. So 4 divided by 8 is a half, right? So we get the same answer, whether you do it sort of the old way or using the exponent laws. But yes, that is very important. If you have a base, the same base, so 2 and 2, and you've got a bigger exponent on the denominator or lower portion, you have to write 1 over the big number minus the small number. So that's how you do that. Excellent question, and that's why. Oh, forgot the whole point of that particular exercise. The whole point of that was to demonstrate why the 0 power is 1. Got off a little track there, sorry. So let's apply what we know. Okay, let's apply what we know here to something like this. Let's say we've got 5 over 3, or sorry, 5 to the power of 3 divided by 5 to the power of 3. Well, let's look at this the traditional way. 5 to the power of 3 is 5 times 5 times 5, and it would be the same thing on the bottom. And you probably know by this point in your math career that if you've got multiplication and you've got a number on top and bottom, you can just cancel them out, and it's 5 divided by 5 is 1, and 5 divided by 5 is 1, and 5 divided by 5 is 1. So you've got 1 times 1 times 1 equals 1. So that's sort of like a traditional way of doing it. Or you could have also gone like this. If you just know that 5 times 5 times 5 is 125, maybe you did something like this, 125 over 125. Well, anything divided by itself is 1, right? It doesn't matter how you did it, you get the same answer, and that is 1. Here's why it works with the exponent 0. Okay, so let's just assume we're going to use, instead of the sort of traditional math methods we've used before, let's say we're going to stick to these exponent laws because they're designed to make my life easier. All right? So here's what happens when you stick to the exponent law, okay? So we've got the same exponent on the top and the bottom. Okay? So what we do is we write the base, and then we do the subtraction, right? So 3 minus 3. Well, what's 3 minus 3? Well, that would be 5 to the power of 0. And I told you every number or every base to the power of 0 is equal to 1. Well, we proved that by, instead of writing it like this, we proved that by taking this in a different direction and saying, well, this is really the same thing as saying 5 times 5 times 5 over 5 times 5 times 5, and just crossing all those out and saying, well, that's really just 1 times 1 times 1 equals, 1. Again, it's not particularly difficult when you're using a 5, right? But it works for every single number. If I'd be using 2 to the power of 4 over 2 to the power of 4, okay, I still get 2 to the power of 4 minus 4 equals 2 to the power of 0 equals 1. So it's really simple. Whenever you see anything to the power of 0, it's just 1. What you have to watch out for sometimes is brackets, and how brackets will change things a little bit. And I'll show you why that's important right now. I'm running out of time here, but we're getting close to the end. All right, so here is where that might get you into just a little bit of trouble. It's when you've got brackets and negative signs, okay? So the thing you need to remember with exponents is the exponent only applies to what it's touching, okay? If you remember one thing from today, remember that. Exponent only applies to what it touches. So let's look at number 1 here. 1 equals 2 to the power of 0. Okay, so if we look at 2 to the power of 0 written like that, the 0 is indeed touching the 2. Therefore, anything to the power of 0 is 1, so that's just 1. That one's pretty easy. Same thing with 13. The 0 exponent is touching the 13, so that's going to be 1 as well. Okay, now here's the one that's a little bit different. You have brackets -5. What is the 0 touching in this case? The 0 is touching the bracket. Therefore, anything that's inside the bracket is fair game. In this case, the negative and the 5 are both inside the bracket, so that 0 exponent is applying to all of that stuff. And all of that stuff to the power of 0 is just going to be 1. Now, why did I make such a big deal about that? Because what if there's no brackets, but there's still a negative sign? That's different, okay? Now, this one's super easy. 4 to the power of 0, the 0 is clearly touching the 4, so that whole thing is 1. And when I say what it's touching, I mean, you know, if it's part of a number like that, okay, I don't mean it's just touching the 6. I mean it's touching this entire number is what I mean. Okay? But it's important when it comes to negatives and brackets that you understand that concept, because over here we don't have any brackets. So what is the exponent actually touching? It's touching the 4, which means it only applies to the 4, which means you got to ignore the negative sign just for a second. I tried to put my finger over it and I couldn't. You got to ignore that negative sign just for a second and say, that's 4 to the power of 0, that's 1. But because the negative sign is not inside brackets with the 4, it's outside of that 1, which means this is actually equal to -1. If you wanted to write this one a different way, it's like saying -1 times 4 to the power of 0 would equal -1, because you got to do, which of these do you have to do first, right? Multiplication or exponents. BEDMAS or PEMDAS or whatever you guys have been calling it, says you got to do the exponent before you do the multiplication. So if I do the exponent first, 4 to the power of 0 is 1. So it's -1 times a positive 1, and a negative times a positive is always going to be a negative. So that's why you have to be careful with these ones. They're a little tricky. This one, on the other hand, has brackets, so the 0 is touching the bracket, which means it doesn't matter what's inside. It doesn't matter at all what's inside. It is going to be 1. So you got to watch out for the negatives and where those brackets hit the negatives. That's the important part of that particular unit. Okay, writing as powers of 10. This one, okay, this one for some reason, students often get it wrong on the exam. I'm never really quite sure why. It's quite a simple process as long as you take it very slowly. Okay, first off, you just start with the very outside number, and I'm gonna throw another number in here that's sort of similar, okay, and show you how you would write that one too. Okay, so you always just start with the number that's on the far left, and you say 3 times 10, okay, because we're writing it as powers of 10, so anything's going to be multiplied by 10. 3 times 10 to the power of, and then just count how many places are after it. 1, 2, 3. So that's 3 times 10 to the power of 3. All right, now why did I do that first? Because I'm taking care of this thousandths place. After you take care of the thousands, then you can go to the hundreds, then the tens, then the ones. So if I say, what is 3 times 10 to the power of 3? Well, I'll just write this the long way. That would be 3 times 10 to the power of 3 is pretty simple, right? It's just 1 with 3 zeros. Well, what's 3 times 1,000? That's 3,000, okay? I'm writing this the long way just to make sure it makes sense to you. All right, now go to the next one. So now we'll go to the hundreds place. So that's 4 times 10, and then you just count how many are after the 4. Okay, so then we've got there the 5 and the 2. So it's then 10 to the power of 2, which is 4 times, well, 10 to the power of 2 is 1 with 2 zeros. 4 times 100 is 400. Then go to the next number. It's a 5. So what's 5 times 10 to the power of, how many numbers are after the 5? Just 1, right? So 10 to the power of 1. So that would be 5 times 10 to the power of 1 is just 10 equals 50. And then you get to the ones place, and it's 2 times 10. How many numbers are after the 0 or after the 2 here? How many numbers are after the 2? There's 0 numbers after the 2. So that's to the 10 to the power of 0, which is really 2 times 10 oops, sorry, 10 to the power of 0. Well, anything to the power of 0 is 1. So 10 to the power of 0 is 1. What's 2 times 1? It's 2. So what happens when we add all of these numbers together? We get 3,452. That's the number we started with. So that is how that process works. Now, the point wasn't, delete this thing here. Now, the point wasn't to get to this point down here. We started with that. We already knew that at the beginning. The point was to write it using powers of 10. I just wanted to show you how that actually ends up working out and why it works out. All right, always work from left to right on those. So when we, what is the actual answer for this question? What would I expect to see as a response? What you should have for a response, and usually you use it in brackets just in case. So usually you would have something like 3 times 10 to the power of 3 plus, and then 4 times 10 to the power of 4. No, 10 to the power of 2 plus, what's next here? 5 times 10 to the power of 1 plus 2 times 10 to the power of 0. That is actually the correct response right there. So when you're asked to write something as powers of 10, that would be the right way to write it. So I'll, what would I expect you to do on an exam or a quiz? If you saw this question, this is what I would expect. I would expect you to go, okay, so that's 3 times 10 to the 1, 2, 3. Okay, 3 times 10 to the 3 plus 4 times 10 to the, how many are after the 4? 2, okay, plus what's next number? 5 times 10. Once you get here, it's obviously pretty simple. You don't need to do a whole lot of brain mashing, right? So that's what I would expect. I also expect that your exponents go from high to low, right? So the exponent 3 is going to be at the front, the exponent 0 is going to be at the back. So that's an expectation. That would be worth like a half mark or something like that. But you can really just look at this question and know the answer and know how to write it right away. It's not like there's a whole lot of work to do with it. The problem, or at least something that is a little bit more confusing sometimes, is when there's zeros in there. So I'm just going to take this question and do it slightly differently. I know we're getting to the end here. I just want to make sure that this is clear. Let's just say we have a number with some zeros in it. So let's say it's like this. So it's very similar looking to this number, but it's actually quite different because this is like 304,502. This is only 3,452. Okay, the question is, what do I do with the zeros? And the answer is nothing. You don't have to do anything. So you just do it the same way, right? You start at the far end, you go 3 times 10 to the power of, how many things are after it? You have to count the zeros because there are places. So it's 1, 2, 3, 4, 5. So this would be 3 times 10 to the power of 5. Now you can ignore this 0 because you don't want to do 0 times 10 to the power of something, because 0 times anything is just 0. It makes no sense. So you skip over it and you skip to the next actual number, which is 4 times 10 to the power of, and then you got to count how many numbers are after, right? 1, 2, 3. So that'd be 4 to the power of 10 to the power of 3. Okay, and then you got 5, which is next. So 5 times 10 to the power of 2. And then you've got another 0. Skip it. Okay, and then just go to the last one, which is 2 times 10 to the power of 1. Or 0, sorry. So when you do this, you got to skip the zeros when you're writing out the powers of 10, but you have to make sure that you include them in the exponent. So does this work out? I mean, this is the answer. But if we just wanted to check and deconstruct it, okay, what's 3 times 10 to the power of 5, right? So that's 3 and then 5 zeros. 1, 2, 3, 4, 5. What's 4? Okay, and we got 3 zeros on that one, right? So 1, 2, 3, and then the 4. I'm lining it up with the right side, so it's easier for me to add. Then I've got a 5 with times 10 with 2 zeros, right? So that should be 500. And then I've got 2 times 10 to the 0. So that would just be a 2, right? Because 10 to the 0 is 1, and 2 times 1 is 2. So if I add this up, I've got a 2 in that column. I got a 0. I got a 5. I got a 4. I got a 0. And then I've got a 3. So I end up with 304,502. So I can check, did I start with that number? and it checks out. So that's a way you could check it, right? You just write the number and then how many zeros behind it. So a 3 with 1, 2, 3, 4, 5 zeros. And then you write a 4 with 1, 2, 3 zeros. You write a 5 with 2 zeros. You write a 2 with 0 zeros. Add them up, and if you get the number you started with, you've correctly written it as a power of 10. Okay, that's all I'm going to do today. This one's just about reading numbers and being able to turn them into powers of 10. So I'll do one, for instance. This site covers 600 hectares. Okay, that's a number. So the number 600, basically they're saying, turn that into powers of 10. Well, it's going to be 6 times 10 to the power of something, right? So 6 times 10 to the power of, count the zeros, 2 zeros. So that's it. Down here, we've got 5,700 or 5,700. Okay, so that's going to be 5 times 10 to the power of count, 1, 2, 3, plus 7 times 10 to the power of, what's after the 7? 1, 2. That's it. Remember, you ignore the zeros when you're writing out this part of it. So as long as your exponents go from high to low, and you don't ever have something like this, 0 times 10 to the power of 3, right? Because 0 times anything is just going to be 0. That's why we don't write it in there. It's pointless. You should be able to handle those powers of 10 and powers of 0. All right, best of luck. Hit me with any questions, and I will see you on Wednesday. If you have any questions with 2.1, 2.2, let me know. Take care.